Okay, so it's very glad to see you all here, and my name is Mr.Chuan, and you can call me Lex, and I'm from Huawei wireless product line, and I'm responsible for the IntelligentRAN in wireless side. And today I will to share some information and ideas and the directions about the intelligence in wireless side. Okay, so our topic is IntelligentRAN enable wireless network acceleration towards ANL4. So first one, let's see. Here are three structure challenges toward 5.5G in the future. So we can see in the maintain domain, we have more sites, more rate, more frequencies in the future. And the number of the frequency increased 3 times, and the number of the logical sites increased 5 times. And also the MTTR, the maintaining time, need to improved 3 times. So we think we face to the complex networks, and it needs more manpower, more work to fix the faults in the future. How we can decrease the OPEX? Okay. The second one is about the power saving. In the future, we know more site, more box, multiple service, multiple type of service, and the traffic may be increased to 100 times. But from the research and the research from the whole world, we got the opinion from the operators. They only want to increase the power consumption less. For example, the carrier V only want to increase the power consumption 1.2 times, and the dictator D and only want to increase the power consumption 1.3 times. So that is the big gap. The last one is about the optimal service experience. As we know, traditional package from the 4G to 4G area to the 5G area, the package changed by the experience achieved 4 times. Into C domain, the package from the by traffic to the by experience, and in the to B domain, we can provide the best effort before, but in the future we need to provide the deterministic experience assurance. So that is very big changes. So we can see it's focused to the 2 points. Customer want to improve the revenue and decrease the OPEX. That's the 2 points which customers in the whole world focus on. Okay. So next we can see what happened. What happened in the industry. Because this information is from the TMF AN1 paper 5.0 from last year. You can see left side. Next 3 years, the operators in the whole world want to achieve the level 4. Level 4 will achieve the 23%. What does it mean? That means the operators want to depend on the intelligence to increase the revenue and decrease the OPEX. By the intelligence, it's very emergency. And so you can see the left side, the right side, the mainstream carriers clearly proposed the strategy of the achieve level 4 from 2025 to the 2027. For example, China Mobile, they have the 5 value goal. For example, the fast service delivery and the excellent network quality. And in Europe, the Orange want to achieve the L4 and becomes the standard next agent elastic and the performance. And also Telefonica, they want to achieve the L4 through the independent evaluation system. Okay, and in Asia, the AIS want to achieve the L4 in the experience and the OM field in the next 3 years. Okay, so let's see what is the thinking, what is the idea from Huawei side. So we have the intelligent architecture. We have 3 layers. First one is the site intelligence. In the site, we can provide some crucial features and functions to optimize the networks as soon as possible. And second one is network intelligence. We introduced the digital twin system to the architecture. And what can we do? I will introduce later and in details. And the last one is the cloud intelligence. It can cross the domain and can orchestration. Okay, so we think our 3D architecture and the digital twin technologies can bring the intelligence from the level 3 to the level 4. So let's see what is the different features between the level 3 and the level 4. In the level 3, about the optimization domain, before we process and handle the fault after the alarm is reported. So we call it response away. But in L4, we think we can fix or we can predict the risk before the fault had occurred. So this is the first key features for L4. And the second one is for the service assurance. Before, we do our best to provide the experience assurance. But we think in the futures, we can provide the deterministic experience to the final user. And the last one is for the network optimization. For example, the power saving. Before, we only can provide the power saving. For example, close the channel, close the carrier, right now. But right now, we think exclude the power saving target. We can also calculate another performance target. For example, the user experience, the coverage, and the interference. The multiple object design capabilities can support the network performance to achieve a better level. So you can see we think there are three main directions. First one is for the intelligent fault prediction. In the key event location, we can do the prediction and give the emergency solutions, right? And the second one is the intelligent service assurance. For example, the live TV assurance, the SLA assurance. And the last one is the intelligent power saving. We can give the best power saving solutions, and at the same time, we can keep the user experience, achieve the better target. So next pages I will to show the details about of the three and more informations. First one is about the fault handling shift from the post-event handling to the pre-event analysis and quickly in event closure. As we know, for example, in the football, we have the football everywhere, right? But during the football game, the traffic of the single event is the largest. It can achieve 40 TB per match. And here are two main challenges. First one is five types users in top sales increase. How can we give the guarantee about the user experience? The second one is for if the fault occurred, how can we fix the fault in 1 hour or in 30 minutes? So because if we want to fix the fault by manually, it's not possible. Okay, so we think if we based on the digital twin technologies and systems, we can do the performance risk predictions. Then we can see which place, which site has some risk. We can provide the pre-solutions, and then during the event, we can monitor the network performance trends in 1 minute. If we found some error or some risk, we can provide we can precise match the emergency solutions and let the solutions execute in the digital twin system and give the result one times. Because if it depends on the human, maybe we need to analyze first and give the solution and execute the solution and then monitor again. again, and then give the result. Okay, it's not good. We need to analyze again. So time is waste. It cannot fix the risk and the fault in 30 minutes or 1 hour. Okay. Next one is about the SA insurance. As we know, traditional package is about the traffic, right? For example, $40 per month. But now, how can we improve the revenue to help? How can we help the customer to improve revenue? Maybe we need to find some more or new business model. For example, can we provide the new packages? For example, is the experience assured packages. We can provide the 200 megabps experience per month, and we can take the money from the users, maybe 200 and more. So, but how can we achieve this target? We have three main challenges. First one is the high cost manual evaluation. Traditionally we need to arrange the FME engineers to the site, to the location, to do the test, get the result. Okay, we can give this user about the experience package, but the human cost is very expensive. Maybe each point we need to spend $18. And the second one is unreliable SL assurance. If we want to depend on the human power to analyze the network status and get the result, but it's not it's unreliable. It's only achieved the 50% to the 70%. And the second is the low resource optimization. For example, if we want to make the slicing to the user, it's statics. But during the normal days, if the user doesn't use the resource, the resource is waste. It cannot be allocated to the normal users. So we think it's a waste for the network. So what can we do? We think about if we based on digital twin, we can do the data modeling and the environment modeling and the resource modeling, and we can create a SLA evaluation map. Then we can say, okay, this point we can allocate this package, and this point we cannot. So it depends on the machine, not depends on the human power. So we think this is a good directions. The second one is traditionally we need to make the slicing by the manual. We need to do the configuration and execute the command to the system. But now we can automatically automatically slice deployment and according to the different service requirements. And the last one is for the, as we think, if the high value packages users that does not use the package or does not use service, we can reallocate the resource to the normal users and improve the user's experience, right? So we think the target is quickly deployment and step traffic simulation. First one from the day level to the minutes level, and then we can improve the service reliability. And the third target is to improve the traffic. Okay. Next one is about the smart energy saving. As I mentioned before, we only concerned about the power saving, one target. But in the future, we think based on the digital twin system, we can consider about the experience, interference, and the coverage. How can we do it? For example, we can based on the many modules and multiple target modules to do the analysis together, which manual cannot do it in short time. So then we can get the best solutions from the system. Okay, this system includes the coverage, solution, and the capability, and the power saving. Then execute one time. And we can also, the digital twin system can monitor the network change. For example, in the daytime, in the daytime, in the morning, here is the high traffic on the road. We can decrease the power saving target and increase the experience target strategies. And in the night, we can decrease the experience requirements and increase the power saving target immediately. So that's why we say that the twin system can do the optimization one-time delivery without the integration on the live network. Okay, next one is for the real-time awareness of the network performance changes and timely optimization and improve the traffic. As we know in the school, here is an example. In the school, in the morning, most part of the students is on the playground, and we think the traffic is higher at the playground in the morning. But at the nighttime, the students are in the teach building, and we think the traffic is burst in at the teach building place. So how can we do this in these scenarios? For example, can we adjust the RF immediately? Can we change the beam immediately? But it depends on the human. Cannot, because normally one cluster or one area needs one person to do this at least one day. You cannot fix these scenarios. So we think, okay, maybe intelligence can do this. Intelligence, these twin technologies can monitor the changes between about the real light networks and output the optimization solutions execute, and then monitor again at the time. So we think it's a good directions and can increase the traffic and users. Okay, that's my presentation about the intelligence. Thank you very much.